Alright, welcome back to the channel. Today we've got another great Make Math Make Sense dollar bills y'all master math classic math video. And we're in the Algebra 2 unit, our course in Khan Academy, and we're gonna go ahead and tackle multiply binomials by polynomials area model, which is actually a lot of fun because the area model makes sense to me. Because one, it helps me. It already has the boxes here for me to keep track of stuff, and then two, um, it helps me understand like conceptually what's going on, right? I'm finding an area of a rectangle that I don't know any of the like values for, right? Because there's variables here, there's some unknowns. So it's like, how do I find area if I don't know what the length and the width are? Well, the concept is the same, right? Area equals length times width. So we're just going to multiply the length and the width of these small boxes, and then once we have the small boxes, we got the area of the small boxes, we're gonna add them all together, the area of the entire thing. And we're gonna write that down here, and we're gonna make sure that we write it in what it asks us to, standard form, highest to lowest exponent. So let's go ahead and get into it. There's a lot of numbers, a lot of change. First I'm gonna write the coefficients here. When I'm finding the area, essentially I'm just multiplying the boxes together. So I've got 1a squared times 1a squared in this box. And I can rearrange this to, using the commutative property, 1 times 1 times a squared times a squared. And 1 times 1 is 2. I know that. And when I multiply bases, I got the exponent rule over here that are the same. So when the base is the same, essentially the shortcut is you can add the exponents, right? But essentially I'm just counting up how many a's in this top left box are being multiplied. Well, there's 4 total. A is being multiplied to itself 4 times. Twice right here. Twice right here. So in the box, total 4. So in this box, I've got 2a. Did I do 1 times 1 is 2? Dude, I've got 1a. 1 times 1 is 1. See how I added them? I'm getting confused. You're adding exponents, you're multiplying. 1a to the 4th, right? So in this box, I got 1a to the 4th. In this box, I've got 2 times 1 is 2. And I'm counting up how many a's there are. There's 2 right here. There's 3 right here. How many total are being multiplied? 3. Top right box, 1 times 5 is 5. Sweet. Times a squared, 5a squared. Bottom left, 3 times 1 is 3. A squared. There's 0 a's here, so no a's are being multiplied down here. Only 2 up top, so 2 total in the box. Middle box, middle box, middle box, middle bottom. 2 times 3 is 6, times a, 6a. And final right box, bottom right, 3 times 5, 15. So now I've got, I'm going to go ahead and erase this a little bit. A to the 4th, right? 1a to the 4th. Now I've got the area of the little boxes. Now I'm going to add them together, and I'm going to write it in standard form to represent the area of the entire box. This also gets kind of confusing because now you're adding again. And this time, you're adding like terms. So things that are the same. A to the 4th doesn't have, there's no other a to the 4th. That comes out. Then 2a to the 3rd. Cool, that's the only a to the 3rd term. Now we've got plus 5a squared plus 3a squared. Cool. Plus 6a plus 15. So if I write it all out like this, that's what you'll see. Okay, and then you'll notice, oh, that's an a term, that's an a squared term, that's an a squared term. Can't we just simplify that instead of saying there's 5a squareds and then plus there's 3 more? Let's just simplify that and say there's 8a squareds. And that's my final answer. Let's make sure. Boom, it's right. Okay, awesome. Example number 2. Yeah, also keep in mind, if we're finding the area, and we set it up, there's 3 terms here, right? Just give you an idea why there's 6 boxes. If we're multiplying 3 terms times 2 terms, we're gonna get 6. That's where the 6 boxes comes from, just FYI when you're setting these up. Okay, 2 times 1 is 2, t to the 3rd. Bottom, 2 times 7, 14. How many t's total are being multiplied? 2. Bottom left, 12. 2 times 6 times t. Top right, t squared times 1. 1 times 1 is 1. I'm not even going to write it. Times t squared, t squared. 7 times 1 is 7 times t. And 6 times 1 is 6. Cool. Now I'm just going to write it all out, standard form, highest to lowest, and then I'll do my combining step. So I've got 2t to the third, sweet, plus t squared, sweet, plus 14t squared, sweet, plus 7, t squared, nope, plus 7, plus 12t, plus 6. Cool, so I've got it all written out, standard form. Got a couple like terms here. Boom, there's my t squared, that's a t squared. And this time we got 2 more terms that we can combine, right? So my final answer would be t to the third, 2t to the third, plus 1 plus 14 is 15, plus 19, plus 6. Notice that after I've multiplied the boxes, the exponents didn't change. 3, 2, 1. So the exponents will not change after you multiply the boxes. Just to make sure that you know that I got it right. Boom! And I got up to 50 points. I get one more. I get 80 points. I want to do it. I want to do it. This one, I'm not. This is a bye. Alright. First top left box. 1 times 1. 1. X times x squared. X to the third. Cool. Top right box. 2 times 1. 2. X times x. X squared. Sweet. Bottom left box. 1 times 9. 9. Whoops. Plus 9. X squared times just x squared. Sweet. And bottom right box, 2 times 9, 18, times x. Cool. I've got 2x squared terms right here. 2 and 9 combined to 11, x squared. And that is how I do it. Good luck.